Lily, this is yours. Questions from last time. Does anybody have any from the previous assignment? Yeah, Jazz.
Can you do number 8 on the worksheet?
Sure.
You're not smarter than me.
I wish I could. Dang it.
Grade in the class?
Okay.
Grade in the class as of now?
Yeah. Yeah.
The only thing I need for that one is just how to do the C value. Like, I'm just
Exactly, that's what you're a failure of a stupid kid.
Okay.
87, bro. What you get?
Gosh dang it. All right. Please stop talking. I know, just the C.
Okay.
I did hear you.
Okay, just making sure.
I'm just trying to get the thing to show up to where we didn't have to try to remember the problem from one page to the other.
Okay.
All right, so it's asking you to describe the transformation. So what we really need to do is identify the values for A, C, H, and K. To start, I want to write it in that general form for a transformation. So I notice that inside my cosine function, the coefficient on x is not 1. So I'll begin by factoring to make the coefficient on x 1. Currently, the coefficient is -1/2. So I'll be factoring a -1/2 out of everything inside the cosine. When I divide -x/2 by -1/2, I get positive x. When I divide positive pi/10 by -1/2, the negatives cancel. And the dividing by a fraction is the same as multiplying by a reciprocal. So when I do that, I get pi/5. Is everybody okay with what I've done there? So my value for A is 1/2. My value for C is -2. My value for H is -pi/5, and my value for K is 1.
Wait, how do you get negative pi? Like, how do you do that?
I divided fractions. So when you're factoring something out, you divide whatever you're factoring out away, correct?
Yeah, but I just don't get how you multiply.
So like if I had 2x plus 4, if I factored that, I would divide 2x by 2 and divide 4 by 2. Does that feel good?
Yeah.
Okay, so here when I'm factoring the -1/2 out, I divided -x/2 by -1/2, and I'm dividing pi/10 by -1/2. So the negatives canceled, so I'm really just doing pi/10 divided by 1/2. Dividing fractions is the same as multiplying by their reciprocal. So I'm just going to think about pi/10 times 2. And then we can just kind of like reduce fractions as we multiply. And that gives me just pi/5.
Okay.
Is that okay?
Yeah.
Sophia?
I know this.
I think so. Jazz, are you happy?
Yeah, I'm all good. Thank you.
Okay. I think we're good on this.
So for the graph and the finding points on sheet 1, for like the I checked the answer key, and for the original points, they're different between sine and cosine.
Yes, they are.
Like, or they're just kind of different with every single like thing within sine and cosine.
So the reference points for sine and cosine are on the reference point sheet. You can see they're different.
Yeah.
And in the future, when we do some of these other trig functions, you're going to see that you have different reference points. Okay, so that's just the way it is. And again, it's coming from, these guys are the quadrantal angles from the unit circle. So the values of sine at 0, 90, 270, 360. And that, I said 0, 90, 180, 270, I forgot one. And the same thing for cosine. Those are just the values for cosine of 0, 90, 180, 270, 360.
And then also for the homework questions, I want to tell at the end, it was like graph this, but it didn't really say like do the points.
Oh, I shouldn't have assigned 11 or 13 through 14.
You didn't answer.
Okay. For
or not 11, 12, it's like 9. Just graph the function on the interval. So I kind of
yeah.
just like, I didn't.
So that's telling you what your graph paper should look like. Your graph paper should start at negative 4 pi and go all the way to positive 4 pi.
Mm-hmm.
So just telling you that like you have a lot of extending to do to fill the space.
Okay, so I kind of, when I graphed it, I kind of just like, drew it based off of the amplitude and stuff. Like I didn't put all the individual points. Is that okay?
You should be putting all the individual points. Yeah. So you should make your graph paper, like make your tick marks so they match up with the x coordinates that you found. And then just like graph what you have and then extend to fill the space, but like put the points that you use to do your extension. Similar to what it looked like when we wrote the answer key out, like I put in the points that I graphed, but I also put in like how I extended things.
Okay.
You know what I mean?
Yeah.
So that's what I'd be looking for there, Sophia. Rita, I see your hand.
Yeah, so in the homework problems, did we learn 7 or 8 yet? Or so?
Did 7 and 8 was an error. I should not have assigned that yet. My mistake. Good call. I knew I made some kind of mistake with this hour because I caught it the next hour. Yeah, so 7 and 8 shouldn't have been assigned yet. We'll talk about how to do that kind of thing today. Giselle.
You should have 14 on the worksheet.
14 from the worksheet. All right, so the first thing I'm going to do is identify my values for A, C, H, and K. Hopefully that's not too difficult there, right? Any questions there? Okay, amplitude is 2. Midline is y equals 1. Period is 4 pi. Frequency is 1 over 4 pi. Any questions with how I did those? So the map I'm going to write is going to be 2x plus 0, comma, 2y plus 1. And then I'm going to use my key points for sine.
The link to sign up for conferences is in today's Learning Stone, and it'll also be emailed to parents Monday morning at 7:50. The conference sign-up will open at 8 a.m.
So those are my points when I grind through my formula. Okay there? So I'm just going to plot. So 0, 1, pi and 3, 2 pi and 1, 3 pi and negative 1, 4 pi and 1, and then we'll just kind of continue extending. So maybe I'll dry that through. So there's my extended. Does that feel okay?
Yeah. Okay. Just scroll down a little bit, just to the points.
How about I zoom out so we can see it all? Okay. And again, don't get thrown on the fractions, right? The fraction arithmetic is
Yeah.
the place where mistakes often get made.
Yeah.
If you're in doubt, just try typing in your calculator. Just leave the pi's out, and then put the pi back in after you've done typed it in your calculator. 3 over 2 times 2 instead of 3 pi over 2 times 2, and just put the pi back in at the end. You know what I mean?
Mm-hmm.
And the calculator can handle all that stuff for you if you're like, did I do that right?
Okay, thank you.
You're welcome. Okay. Last call on homework questions. Great. So today we're doing like no new content. We're going to do some example problems with the next type of problem that we're going to talk about. I'm just going to do a couple of examples here together, and then I'm going to let you guys work for the remainder of the hour. So you're going to have like 40-something minutes or more at the end to just do some math homeworks. Okay? Now, this topic that we're about to do tends to be a little bit tricky because you really have to understand what's going on. So just wanted to prepare you for that. Okay. So the first examples here, we're giving you a picture, and we're asking you to identify the function based on the picture. So the tools that I'm going to use for this are going to be those key attributes that we talked about yesterday. So I'm going to use the midline and the amplitude and the period, and then the idea of that transformation map to figure everything out. Everybody okay with that plan? Okay. So the place where I like to start is the piece that's easiest to identify visually, which is the midline. If I look at this picture, where is the midline at?
0.
The x-axis at y equals 0. Right? And remember the midline, how do we find the midline? Y equals k. So that tells me k is 0. So that's one. Oops. Coefficient down. Everybody good? Yes? That's okay? The next thing I'm going to do is look for the amplitude. How do I find the amplitude, or what is the amplitude? It's the absolute value of A, and it's the distance between half of the distance between the two extrema, or just the distance from extrema to midline. Either one is fine. They both mean the same thing. So for example, that is my amplitude. So what does that tell me? It does not tell me A exactly. It tells me the absolute value of A. I don't know yet whether A is going to be negative or positive. That piece I will not be able to figure out till the end. Everybody okay there? Are we doing so far so good? The pace is appropriate. I haven't done anything to confuse you yet. Okay. The next thing I'm going to do is find the period. What is the period again? 2 pi times the absolute value of C. But in words, what am I looking for with the period? Right, the length of the longest non-repeating cycle, right? Well, in our case, that is one period, right? It's the whole shebang. Let's see. This is negative 2 pi down here. I know it's hard to read. in the picture, and that's positive 2 pi up there. So my period is 4 pi long. Everybody's okay with that? So that tells me that the absolute value of C then has to be 2. So C is 2, or it's negative 2. Is everybody okay to hear? Okay, so now we're going to start finishing this off. So when I write my final answer, I could write every one of these, I could write as a sine function, or I could write it as a cosine function. A little bit. And it doesn't matter, right? There's a correct answer either way. Remember when we looked at the basic graphs of sine and cosine, we noticed that they were the identical shape. They were just translated horizontally. So I could answer this either way. We're going to write both answers just to show you what I'm doing. Is that okay with everybody? Okay. So now what we're going to do is we have to sort out whether we want our A or our C to be positive and negative, or whether we should make our A or C positive or negative. This is what I do, is because the A's and C's just do reflections, you can choose to do all of your reflection with either A and either C, and then pick up any other thing with a translation horizontally, right? If I do a reflection, that's the same thing as like translating it horizontally also. Do you guys agree with that? So if I flip that graph over the x-axis, that's the same as like sliding it some direction also. I would get the same shaped graph if I just had pulled it one way or pushed it the other way. I could get the same graph. Everybody kind of agree with that? So what this means is all I really need to do is I can choose A or C to always be positive, is what this means. Because I can pick, if there was a reflection going on there, I could pick it up with the H later on. Everybody's okay with that? So what I do is I always choose my C to be positive. So I'm just going to pick C to be positive. Could you do it by picking C to be negative? Sure, but I don't think it ever makes the problem easier and will often make the problem more difficult, potentially. I mean, slightly more difficult, but like enough to, why would I make my life harder? Okay, so you can always choose either A or C to just be positive. My advice to you is just choose the C to be positive. Everybody's okay with that? Now we need to decide two things. We need to figure out the sign for A and the horizontal translation going on. Okay with that? So to do this, what I'm going to do is I'm going to take a point from my parent function and map it to some point on my resultant function that I'm looking at. Okay. So for using the sine function, which point from the parent function is going to be the easiest one to deal with? 0, 0. Why 0, 0? Because the A and the C no longer matter, It makes the algebra a little bit easier to use. So this is just going to be h comma k then. Is everybody okay with that? So all I'm going to do now is think about what kind of point 0, 0 is on the graph of sine. Is that a maximum? Is that a minimum? Or is a midline point? That's a midline point. Now, there are actually two types of midline points. If you think about the graph of sine, if I had picked this midline point, it has a minimum before it and a maximum afterwards. But this midline point has a maximum before and a minimum after. Do you guys see how there's two different kinds of midline points? So if I look at the graph of sine, just regular old graph sine x, what type of midline point do we have? It's a minimum and then a maximum type of midline point. Right? If you looked at the graph of y equals sine x, to the right is a maximum and to the left is the minimum. The way I'm going to represent that is with the down arrow before the midline and an up arrow after the midline to show that there's a minimum, midline, maximum. That's the kind of midline point I'm using. Everybody okay with that? What I'm going to do now is I'm going to go to my picture and I'm going to pick any midline point from my picture. It does not matter. Yes, sure. Does not matter which one I pick. Which one would you pick? I mean, I'm picking 0, 0, right? Okay. So this is going to be what type of midline point is 0, 0? This is the maximum is to the left, then we have the midline point, and then we have the minimum. Everybody see that from our picture? If I compare, what do we notice? They're not the same, right? Do you guys agree with that? They are both midline points, but they're not the same kind of midline point. What does that tell me? That tells me the sign for A. If I have opposing midline points, the sign for A needs to be opposite. If they're the same kind of midline point, then the sign for A needs to be positive. Sophia.
I'm sorry, could you explain the midline point up and down?
Yes. So all I'm doing is I'm describing what kind of midline point I have. Because if I look at the blue midline point here, this one goes, I have a maximum, I have a midline point, and then I have a minimum. If I look at this midline point, I have a minimum, a midline point, and then a maximum. Those are two different kinds of midline points. So the way I'm just going to notate this is with an up arrow for a max and a down arrow for a min. Is that okay? So that's all that notation is trying to signify, is indicate to myself that I'm using two different kinds of midline points, which is fine. I can map a midline point to a midline point, no problem. But I have to be careful about the kind of midline point I'm using. Now, had I used, for example, the midline point pi over, or 2 pi comma 0, that's the same kind of midline point, so I could use a positive a there, right? There's infinitely many choices. It's just about like which midline point I want to use and making sure that everything else matches up with that. Is that okay? All right, so we have our A, we have our K, we have our C. All of those are fixed now. Oh, I forgot, I highlighted the wrong thing. The K we found was the very first thing. The K was 0. Oops. So our A was -2. What do we still have to find here? What are we still missing? The H. But you know what? Look. We already found it. So by using the parent function point 0, 0, whatever midline point we mapped it to, the x-coordinate of that midline point is just going to be H. I'm done. Now, had I picked a different point other than 0, 0, now there's a little bit of algebra to solve. So you'd have like, you know, like 3 plus H is equal to 7 or something, and you have to do like a little bit of trivial algebra to solve that. But it's just like, it's a little trivial. Oops. So our answer then for sine, we'd have, or one possible answer, I should say, was that -2 times sine of 1 over 2 times x minus 0 plus 0. Now, could you simplify that down and just write -2 times sine of 1/2 x? Sure. I'm going to put all the coefficients in so that's like super obvious how I put that together for you, since we're doing notes right now. Everybody's good? What if we had decided to do the cosine graph instead? Yeah, so if we had decided to do this as a cosine graph, everything stays the same up into when I picked my sine for A and when I found my H. So I still know K is 0. I still know that C is 2. I don't yet know whether A is going to be -2 or +2, and I don't know H is where we're at. We're going to do the same thing, though. We're going to take a point from our parent function and map it to some point in our transformed function. And as I heard Nolan already suggesting, the point that he wants to use is the point 0, 1. What type of point was 0, 1 on our cosine function? That is a maximum. So in our transformed function, the point I need to pick is the point from my transformed function that I'm going to pair up with that 0.01 needs to be or a min. If I'm using a max, the A has to be positive. If I used a min, then the A would need to be negative. Everybody's okay with that? So let's say I just chose this point here. which is negative, that's a max, negative pi comma 2. Everybody's cool with that? Because I'm going from max to max, that tells me that the A needs to be positive.
Wait, if we go from max to negative?
Exactly.
What if it was going from max to minimum?
Can't do that. You can't map, like you can't transform a midline point into a maximum or minimum, or you can't take a maximum minimum and turn it into a midline point. You can only take extrema to extrema, midline to midline. Sophia?
Why can't we choose 0, 0?
Because that's not a point on the cosine function. So if you look at the key points on cosine, or the reference points, I keep calling them key points, we have to pick something from here. And the one I like is the one where 0 is the x-coordinate. Is that, Giselle, is that the same question? Yep, good questions. Okay, so I have that. That's giving me my sign for A. And what is this telling me? H is just going to be negative pi. Again, because I'd have C times 0 plus H.
Why is there K is given to 0?
Because we don't have K is 2. We have A plus K has to equal 2.
Wait, how did you just find it? Sorry.
So let's, maybe we'll fill this in first. Okay, that's okay. So when I plug this in, I have C times 0 plus H, and then A times 1 plus K. So this is the point H comma A plus K. I'm going to map that to the point negative pi 2. So that's telling me that H is negative pi, right? And it would tell me that A plus K is 2. Now I don't need that for anything because I already know that A is 2 and K is 0, but that matches up perfectly with what I would expect. Just to show you that like everything makes sense, that A plus K should equal 2. And they do. We already knew A and K, so we just had to plug them in. So of the infinitely many answers I could have had here, this is one of them. Is that okay? Okay. Can we do the next one without writing so much down? Or do you want to do like super detailed step through?
Let's try without it.
All right. Yes, sir.
Would we have to do both, or can we just choose cos or sine?
It just depend on the directions. Sure.
Are we doing example 3 and 4 too?
Uh-huh. All right. K is 1, right? A is 1 or negative 1. C is a half. Or negative a half, but I'm always going to pick my C to be positive. Is everybody okay how I've scooted through those three values already. Pi is the period, right? If I go from max to max, that's one period. So pi is equal to 2 pi times the absolute value of c. So if I solve, I get 1/2. Either positive or negative because it was the absolute value c. But I'm always going to pick the c to be positive. We're just going to choose that. What's that? Pi is equal to 2 pi times c. When you solve for c, you get 1/2. Or negative 1/2. Because it's the absolute value.
Wait, I don't get to see.
The period, which is pi, is equal to 2 pi times the absolute value of c. Right? That's how we find the period. Right? Just some little fractiony divisions. That's the equation for the period. 2 pi times the absolute value c. And the period I read from my graph in this particular graph is pi. So on this particular graph, the c has to be either 1/2 or negative 1/2. We're going to choose it to be positive 1/2. All right. If we're doing sine, let's say we pick this midline point. That appears to be pi over 4, comma 1. Because it's halfway in between 0 and pi over 2. Everybody agree with that? That 1/2 of 1/2 is 1/4. So that would be pi over 4. If I'm mapping that in my sine graph to the point 0, 0, 0, 0 is a midline, or is a minimum midline maximum. That's the type of midline point that is. That's the opposite kind of point, midline point. So that's telling me that my A is negative. But it also tells me that my H is just going to be pi over 4. That if the x-coordinate on my parent function is a 0, the x-coordinate I'm mapping it up to in the resultant function is always just going to be h. Olivia.
Can you explain the midline arrows one more time?
Yes. So if I look at the graph of sine looks like this, assuming that's the x-axis there. So I have a minimum, then the midline point, and then a maximum. So that's why I wrote it with a down arrow for the minimum, and then I have my midline point, and then an up arrow.
Oh, okay.
If I look at the one I picked in the picture, I have a maximum, so I drew an up arrow, a midline point, and then a minimum, so I drew the down arrow. The point is that they're the opposite type of midline points, which tells me that the A needs to be negative.
Okay, that makes sense.
This piece here is just like a good fact to memorize, that that's the kind of midline point that 0, 0 is.
Yeah.
No.
So you'll be giving the starting reference points on the class.
Yes. Yeah.
So who had that?
Sure. So guess what, guys? We just did it. That was it. It's done. That's the answer for sine. Yeah, Gigi.
For like the arrows that go down midline, why don't we just do like if it goes down after midline?
I mean, you could have picked this one and used that midline point. That's fine.
I mean, like deciding if it's like supposed to be negative, like A is supposed to be negative or not, and then one half. Why can't you just instead of saying that like goes up before the midline and then down after, so it just seems goes down.
Sure. That's fine. You can just look at one thing if you want. That's okay. You don't need both sides of it. You could just look at before, after. I usually do both of them just because it's, I don't know, it seems a little bit more clear to students when I do it that way versus just like one side of it. But one side of it's enough, either before or after. It's okay. Yeah, let's do the cosine one. So if I'm doing cosine, we're using the point 0, 1, which is a maximum. Which point do you want to match that up to? How about 0, 2, right? That's a maximum also. So what does that tell me?
That
A is positive, and what's the h got to be? Just 0. Again, since the x-coordinate from my parent function is 0, the x-coordinate on my transform function is just going to be my h. Olivia?
Would there ever be like a problem where you like find both sine and cosine? Or like would it be okay if I just knew how to do one? I don't know how to do both, but
depending on the instructions, they may ask you for one or the other. They might ask for both. I think in some of the worksheets I ask for both. Once you have the one, the other is like super fast, right? Because almost everything is the same. The only thing that's going to be different is the sign on A and the H. And it's potentially different. Well, the H will be different, but the sign on A could be the same. Right?
then H is 0?
Yeah. Yeah. That's it. We're done.
Would you just change the 1 from 1/2 to 2?
Absolutely, yeah. I'm just filling it into the formula so it's clear what I did for you guys when you go back and look at your notes. But yes, you could simplify that. You could just write cosine 2x plus 1. Done. That's fine. Rita.
Will you ever actually or will the x, or like to find the h, will the x always, or will the h always be like what the x is? Or will
No.
it be math?
On a picture, yes, you can always pick a point to use so that the h is the same as the x coordinate. In a word problem where you don't have all of the information, you might have to do some extra solving, and that's what we're going to look at in the next set of examples here. And what you'll see in some of the homework problems. Sophia.
So for the homework in the last class, I'm just going over it again. And like, for the say the trend x, y, let's see the x or c times x plus h, whatever. I'm doing 1 over c. Is that wrong?
Yes, unless you're pulling unless you're pulling the c, unless you're calling the 1 over c in the when you're pulling it from the equation. So you might be doing it, you might be getting the correct answer because you're calling 1 over c the value for c.
Yeah.
Like if it was sine of 2x and you called c2, then you're fine if you're using 1 over c when you're graphing.
Okay.
You know what I mean?
Yeah.
Because you flipped it now twice.
Yeah, and it just goes back.
And so it's like not flipped at all.
Yeah.
But like yes, that it does matter. All right. Let's go to one of these word problems. And the word problems, there's a bit more variation about like what can happen. All right. So construct a sinusoid with an amplitude of 4, period of 3 pi that passes through the point 3, 1. When we say sinusoid, what do we mean? A sine or cosine function, right? Either one is a sinusoid. So right away, amplitude of 4, what does that give me? Well, it gives me the absolute value of A, right? I don't yet know whether I want -4 or +4. What does the period of 3 pi give me? Yeah, it'll help me find the absolute value of C, right? So I know that C is 3 over 2, or negative 3 over 2. We're always going to pick the C to be positive. Now the last piece is we have this point. Okay, what are we still missing? We don't know H, we don't know K, and we don't know the sign for A. I can take care of all that in one shot. So which trig function do you want to use here, sine or cosine?
Sine.
Okay, if we use sine, which point do we want to map 3, 1 to? 0, 0. Is that okay? What kind of point is 3, 1? Does it tell me it's a midline point? No. Does it tell me where it is, though? No, it doesn't tell me what kind of point it is at all. So all right, you're right. It is. I do know where it is. Yes, sorry. I meant like where in the graph is it? So you know what I can do then is it's my choice what kind of point I want 3, 1 to be.
Yeah.
So I am going to pick. I'm going to pick 3, 1 to be the exact same kind of midline point as 0, 0. What does that tell me? So the A is going to be positive. And because the x coordinate of my parent function is 0, what is the value for H?
0.
3. And because the y coordinate of my parent function is 0, what's the value for K?
1.
1, and I'm done.
Oh.
Yes. If you're not told what kind of point it is, and you're using a sine function, absolutely. Yes.
This is like not really about this question, but just in general.
Okay, can we hold off on it then?
Yeah.
Okay, that's okay. What we're doing is kind of complicated.
Don't worry.
If I don't want to exit a bunch of tangents.
Don't worry.
Okay. All right. So what if we had made the unfortunate decision of trying to use a cosine function here? Which is fine. It's not really that unfortunate. So 0, 1 would be the one that we'd want to use, right? 0, 1 is a maximum. So what kind of point should we pick 3, 1 to be? Maximum. So again, that tells me that the A is going to be positive. And because the x coordinate from the parent function is 0, what does the y coordinate have to be? 3. But look at that. So what does this tell me? A times 1 plus k has to equal 1. Because the way we find the y coordinate in our transform function is ay plus k, right? So our a we said was 4. So k would have to be negative 3 here. Now that wasn't difficult to do, but that's tough to remember that you have to do that, right?
Wait, can you repeat what you just did like that?
Yes.
Really not that deep.
So the issue was, in the parent function, the y coordinate was not 0. So it does not automatically give me k. I have to transform that y coordinate into 1. The way we transform a y coordinate is a times y plus k. That transformation needs to give me the 1. So a times 1 plus k had to equal 1. My a was 4, so 4a plus k, or 4 times 1 plus k is equal to 1, so k is negative 3. Now again, if you have your choice, which one should you pick?
Sine.
Sine. Much easier, right? Not that cosine was difficult, but there's one extra little complication that you have to remember that's like, if I can just avoid having to do that by choosing intelligently, why wouldn't I do that? Work smarter, not harder. All right, this is our last example. So here it says, construct a sinusoid that has a minimum value at 510 and the next maximum at 1532. Okay. So I would start on a problem like this by drawing a little picture of what's going on. Everybody okay with that?
Yes.
All right, where's the midline going to be? It's going to be like here, right? Halfway in between the two? Well, what's halfway in between 32 and 10? Well, there's 22 units between 10 and 32.
Right.
So half of that is 11. Everybody's okay with that?
We just went halfway in between 32 and 10. On the graph. Oh, yeah. Okay. Okay.
Oh, no. That's, I'm sorry. We didn't do that. We found A. My apologies.
Wait. So you're 32 minus 10 to get.
So I found the distance because I subtracted. My apologies.
Oh.
Right? If I did max coordinate minus min coordinate, that's the distance between the two, right? And if I divide that in 2, that's the amplitude. Sorry. I should put that here. Okay. Is everybody okay with what we did there? No. The midline is going to be 11 up from the minimum. Right? So this must be...
It is 21. Oh my god.
So...
But I was right. I was right the first time.
Or... Or you could just find the k by taking the average of the maximum y coordinate and the minimum y coordinate. That'll give you halfway in between the two. Right? It's like the midpoint between them. Everybody's okay with that? All right. So we start, so how far is here? That's 11 units, right? And up from the x-axis, how far is here? 10.
Isn't it? Oh, yeah. Why isn't it equal?
Because A is the amplitude, so that's the distance between the point and the midline. No. So K is the midline.
Thank you, if you have trouble visualizing that, just use the two formulas that I outlined, right? You can just do that. That's okay. If you're a pictures person, there's some pictures. If you're a visual person, there's some, or if you're not a visual person, then there's some equations. That's fine. Either is okay. They're both going to do the same thing.
I don't want to do no.
Shh. All right. On to C.
Oh my God.
Okay. What do we use to get C? The period. So how much of a period do we have drawn here?
Half.
Looks like half, right? Because if I go like that, and I go from max to max, that's one period. I know the minimum is in between, and then a max again, so I have half a period, right? Everybody agree with that? So I know that 1/2 my period is going to equal, well, let's just put it as an absolute value, x max minus x min. Because we want a horizontal distance for the period. So what that's going to be is 10. So how far is one period then? 20. And how do I find a period? So my absolute value C should be 10 over pi. And we're always going to pick the positive for our C. So keep in mind here, guys, the picture was how I knew it was half a period. Without drawing the picture, stop talking. It's going to be very difficult to figure out how much of a period you have. You might have a half, you might have a quarter, you might have 3 halves, you might have 5 halves, who knows, right? So you got to really look at the picture and look at what you have. Okay, draw the picture. It matters. All right, last thing we need to do is figure out the sign for A and our H. Which trig function would be the easier one to use here? Nope. Cosine. Why cosine? Why is cosine easier? Because all we know are the location of a max and a min. Those are extrema. Can I use 0, 0 to map to those? No. I would use cosine here. Sure, we can. It's just a pain. So which one of the two would I want to use here? Would I want to use 15, 32 or 5, 10? I mean, I would do 15, 32 because it's a max. It doesn't matter, though, because what the max to max is telling me is that my A has to be positive. And because my parent function x coordinate is 0, was it tell me my H is? 15. So I can say y equals 11 times cosine of 1 over 10 over pi times x minus 15 plus 21. Now, if we had used sine, and we made that unfortunate decision to do that, I have to pick an extreme point from the parent function of sine. So let's say I pick the maximum. And let's say we pair that to the maximum here. So that, again, it tells me that my A is positive. But to find my H is not going to be so easy, right? I'm going to have Cx plus H is going to equal that, oops. Let's say, let's do this. Cx parent function plus H equals x from the resultant function. So my C was 10 over pi times pi over 2 plus H has to give me 15. So H had to be 10. Now, why would you want to do sine to do this one? I wouldn't. In general, if I have a midline point, I'm going to use sine. Or if I'm not told what kind of point it is, if I have freedom to choose where that point needs to occur on my graph, I'm going to use sine and just make it a midline point, choose for it to be one. If all I know about are extrema, I'm using cosine, because it just makes the H, finding the H a little bit easier, right? That's the only thing that we can make easier by being clever, is how easy it is to find that value for H. All right, that took way longer than I thought it was going to, and that's okay. I apologize for lying to you guys about how long this was going to take. I really didn't plan on it lasting that long. So we got 7 and 8, 13 and 14, and then worksheets 2 and 3. I would probably do them in the opposite order. I do worksheet 3 first and worksheet 2 second. When is this going to be due, though?
Next 2 years.
What's that, like 10-9 or something? Yeah.
Like 2 weeks. You are very generous.
What's, oh, sure. No, because the other class hasn't had a chance to ask questions about it. That'll all go in there. What's due today, or due this weekend? 50 through 61. Worksheet 1, and then the review. This is all chapter 2 stuff. No, that's not how you spell review, is it? There's an I. FYI, next class on Tuesday. No, I'm not saying there's homework class. Next class on Tuesday, we're going to spend some time letting you guys work on worksheets 2 and 3. Okay? So try to do some stuff. You don't have to finish it because we'll have some time in class to work again, because you will have questions on things. You will want to talk to people about it. I think it's very productive to use that time while we're all together to do some work on it. So don't kill yourself trying to do all of it by Tuesday. Now, Thursday next week might be a good day for a homework quiz. But Thursday next week might be a good day for that. But it gives you a chance to, like, you'll have a whole day on Tuesday to, like, really grind at this stuff and get good at it, right? Feels pretty realistic, I hope.